Hi friends, in this video we are going to conducting experiment of Ohm's law. So actually to conduct this experiment we required some few components. So in that, first thing is we required breadboard, and the second thing is a regulated power supply. You can observe this is the regulated power supply, okay, and which convert from AC voltage to DC voltage, okay. And the third thing is we required the meter, okay. You can observe that here 0 to 20 milliampere name is there. It means that this meter is the ammeter. So we know that whenever we are going for the verification of Ohm's law, so what we need to do actually, so we need to use the formula I is equal to V by R. Based on that formula we can say that whenever the value of resistance is increased in the circuit, the value of current will decrease, okay. So from this experiment we can observe that whenever we are increasing the value of resistance in the circuit, the value of current is decreasing. So that particular current value is displayed by this particular ammeter, okay. And here by using this regulated power supply we are going to applying the voltage to the circuit, and you can use the value of voltage from the range between the 0 to 30 volts, okay. So the another thing is we required some values of, or we required some components of resistances, okay. You can observe that. So I'm using this one resistor, and also I'm using another resistor because, so first I will conduct experiment with one resistor. After getting the value of current for one resistor, with the help of that reference voltage and current, you can increase the value of resistance in the circuit, so that whenever the value of resistance is increasing in the circuit, so that the value of current will decrease. So to prove that condition, so first I am going to connecting the circuit with one resistor, and after getting the value of current from the circuit, then I am going for the second case, that is by applying one more resistor in series with the previous resistance, okay. So now take the breadboard, okay. Now first what I need to do, first I will conduct the experiment with one resistor, and after that I am going to adding one more resistor in series with this particular resistor, so that you will get the clarity when the value of resistance is increasing in the circuit, then what happened to the current, okay. So because of this particular experiment I think you may get clarity what is happening in the circuit, okay. So just see here, first I am connecting one resistor like this. For example, I'm connecting resistor like this, okay. You can observe that I placed this particular resistor on the vertical lines, okay. So I'm using two vertical plates to place this resistance, okay. Now this is one part. Now what I need to do, I need to apply, or I need to connect the positive terminal of the regulated power supply to the this particular terminal of the resistor, and the positive terminal of the ammeter is connected to the second terminal of the resistor, okay. Now I am connecting that particular connection. Now you can observe that this is a regulated power supply, and here I am using two different output terminals, okay. So this is positive terminal and this one is the negative terminal of a regulated power supply. Now what I need to do, I need to connect this positive terminal, okay. I need to connect this positive terminal to what, the one side of the resistor, okay. I'm connecting this particular positive terminal to the one side of resistor like this. And after that what I need to do, I need to connect the positive terminal of the ammeter to the another terminal of the resistor, okay. So you can observe this. So this is the ammeter, and here red indicates the positive terminal, black indicates the negative terminal, so that I'm connecting this particular positive terminal of the ammeter to the another terminal of the resistor like this, okay. I placed the positive terminal of the ammeter to the another terminal of the resistor like this. Now what is the remaining, you have the negative terminal of the RPS, and as well as you have the negative terminal of the ammeter. So we need to short these two, okay. I need to short these two to close the circuit, okay. So you can observe that, so I'm connecting, okay. For example, I'm placing this particular, yes, so I'm placing this particular short connection here. You can observe that I'm placing a negative terminal of regulated power supply and a negative terminal of the ammeter I'm placing on the same plate, okay. That is on vertical plate, okay. Now you can observe the complete connection, okay. Now I will show you the complete connection how I connected. Now you can observe I have taken one resistance. One terminal of the resistance is directly connected to the positive terminal of the regulated power supply. You can observe here positive terminal of the regulated power supply is connected to the resistance, and negative terminal of the regulated power supply is directly shorted with or connected with the negative terminal of the ammeter like this. Okay, and positive terminal of the ammeter is directly connected to the one more side of the resistor like this. Now you can observe, whenever I am going to applying some voltage to the circuit with the help of the regulated power supply, then because of the closed circuit there is a flow of some current in the circuit. So that particular current is displayed by the ammeter I am using in this experiment. And from this experiment you can observe that whenever we have one resistor, at some value of voltage you will get some current. But whenever I am going to increasing one more resistance in series with the previous resistance, so that at the same voltage you are going to get the value of less current in the circuit. So that indicates the Ohm's law. Okay, so now you can observe that I am applying some voltage by switching on the regulated power supply as well as the ammeter, so that I am applying some voltage, so that some amount of current will displayed by the ammeter. Now you can see the value of applied voltage initially 0. Okay, and now what I am doing, just I am applying some voltage, to the circuit. For example, I am applying 5 volts, just to 5 volts to prove the condition. Okay, now I am applying 5 volts voltage by varying the knob which is provided for. Otherwise I can apply only 4 volts. Okay, anyway our target is to prove Ohm's law in practical. Okay, now you can observe that, yes, now 4.1, now the value of applied voltage is 4. Okay, now you can observe that by varying the knobs which is provided by for the RPS, just I applied 4 volts to the circuit. Now by applying these 4 volts, what is happening, definitely some amount of current will flows in the circuit because the circuit is closed. So that whatever the ammeter I connected in the circuit, that ammeter is showing the value of 2.05 amperes, but here the meter is 0 to 20 milliamperes. So that whatever the value you are getting in the ammeter, definitely that value in the milliamperes only. Okay, now you can observe that what is actually our target from this experiment means, by connecting one resistance in the circuit, by applying 4 volts, you are getting the value of current as 2.05 milliamperes. Okay, it means as per the formula I is equal to V by R. Okay, as per the formula I is equal to V by R, you are applying some voltage and you connected some value of resistance in the circuit, so that the value of current which is displayed in the ammeter is 2.05 milliamperes. Now what I need to do, just simply I am connecting one more resistance in series with this particular resistor, so that in the circuit the value of resistance is increased. So when the value of resistance is increased, so that I will be decreased. So that is the reason why I is equal to V divided by R. So in that formula I am increasing the value of denominator term, that is resistance. I am decreasing the resistance value, then whenever the denominator term is increased, so that always current will decrease. So to prove that, what I need to do, just I am disconnecting this complete circuit and I am placing one more resistor in series with this previous resistor, so that at 4 volts definitely I am not going to get the value of ammeter 2.05 or 2.06 milliamperes. Okay, now what I need to do, just I am switching off all the connections and all the equipments components. Now what I need to do, just I am adding one more resistor in the circuit. Okay, so you can observe that I am switching off this. Here also same, I am switching off this. Okay, now you can observe that I am adding one more resistor in series with the same circuit. Okay, so just to add external resistance or one more resistance, just what I need to do, just you can remove the connection of positive terminal of the ammeter and take one more resistor, and you can add this one more resistor in series with the previous value. Okay, you can observe that how I connected the series connection means, so in the breadboard central two partitions always act as a single point in the vertical, so that just I placed this resistor in the vertical. Okay, you can observe this. Okay, I placed these two terminals in the same vertical line, so that both are connected in series. Now whatever the connection I removed from the circuit, that is positive terminal of the ammeter, again I am taking this terminal and again I am connecting in series with the second resistor. Okay, it means that in the circuit the value of resistance is increased. Okay, now what I need to do, again I need to switch on the equipments, and at the same 4 volts I need to check whether the current is same or not. So you can observe that definitely the value of resistance is increased means definitely current will decrease. Okay, so I'm switching on and I will apply 4 volts. So now you can see that I switch on the RPS as well as the ammeter. Okay. Now you can observe this value. I am applying 4 volts by using regulated power supply, and in the circuit I increased the value of resistance by connecting in series with the previous resistance. So for the same value of voltage 4 volts, how much amount of current I am getting, you can observe here. So by observing this value, we are getting 0.98 milliamperes. It means what? Whenever we are increasing the value of resistance in the circuit, so that the current flowing in the circuit definitely will decrease, because I is equal to V divided by R. It means that the value of resistance in the denominator is increasing. It means that the current which is flowing in the circuit must be decreased. Okay, so like this we can prove the Ohm's law experiment. Thank you so much for watching, and please do subscribe my channel for more updates.